Welcome back to the Infinite Scale Lab. If you listen to mainstream financial media, they will tell you that Nvidia's multi-trillion-dollar monopoly is entirely protected by software. They talk about CUDA, develop lock-in, and proprietary software stacks. But as a physicist, looking at the brutal scale of modern machine learning clusters, I'm here to tell you that software is only half the story. The biggest threat to NVIDIA's dominance isn't competitor software. It is the unyielding law of nature, specifically the power wall and the memory wall. As AI models scale up, the primary challenge is no longer logic execution. It is the physics of moving data. Let's head over to the lab monitor and unbox exactly how NVIDIA is rewriting the laws of semiconductor scaling. We are looking at our latest lab diagram illustrating this exact physical threshold. Look at the left side of your screen. This represents traditional communication between a processor and high bandwidth memory arrays using copper wires. When you push massive electrical currents down these tiny copper paths, the moving electrons constantly collide with the copper ion lattice. In physics, we call this chaotic electron scattering. It manifests as standard electrical resistance. According to Joule's first law, written right here as P equals I squared R, the energy lost as wasted thermal heat scales exponentially with the current. In a massive data center cluster, this creates a catastrophic power wall. Traditional air cooling back plugs simply cannot dissipate this high heat flux fast enough. The silicon begins to melt, forcing the chips to thermal throttle and slow down. Now shift your eyes over to the right side of the diagram. This is NVIDIA's structural solution, and it is their true hardware Moat, silicon photonics. Instead of routing sluggish electrons through resistive metal links, NVIDIA is embedding microlasers and physical silicon dioxide optical waveguides directly into the substrate layer. Data packets are converted from electrical voltages directly into light waves. The velocity of our signal jumps immediately from slow electronic drift speed up to the absolute speed of light within a dielectric, calculated as V equals C over M. Because photons are bosons and carry zero electrical charge, they don't suffer from chaotic electron scattering or crosstalk interference. They flow perfectly down the waveguide with almost zero power loss and negligible heat creation. This breaks the memory wall completely. This is the critical inflection point that tech investors are missing. Designing an advanced chip logic layout is a software design problem, but building a physical commercial data center infrastructure that replaces copper wire frameworks with optical networks while managing high volume liquid cooling loops is a deep physical industrial engineering challenge. NVIDIA's competitive advantage has officially scaled past the microscopic transistor logic level. They have successfully locked up the systems level infrastructure of physical cluster dynamics. Competitors can build cheaper logic chips all day long, but until they can safely cheat the unyielding thermodynamics of copper connections, they cannot touch this moat. If you want to continue unboxing the true physics moats that define the future of technology and finance, make sure to read our fully analytical article linked in the description below. Hit that subscribe button to join our network here. at the Infinite Square Lab. Leave your thought on silicon photonics in the comments, and I will see you next time.